In this video, I'm going to go through capital budgeting methods. Specifically, we're going to talk about NPV, IRR, MIRR, profitability index, and payback period, and some issues with these. In the next video, we're going to take a look at how to apply these using Microsoft Excel. For this lecture, I'll be using two different calculators to show you how to work problems, work capital budgeting problems. The first calculator I'll use is a BA2 Plus. So this says professional. You don't need the professional one. I wouldn't recommend getting the professional one because it only does one additional thing. You might have a BA2 Plus. It might be a brown or a gray or a grayish brown color, and that's fine. It does everything this one does. This one is just prettier because they give me, Texas Instruments gives me this one. That's the only reason I have it. I'll also be using a TI-84 Plus CE. I know some of you that may have been undergraduate students more recently might have one of these or something very close to it, like a TI-83 or a TI-89. They all work the same way. I like this one because it shows you all the inputs in one place, and so I'll use this for some examples as well. So let's get started. The first item on the sheets that I have out online for you says, what is capital budgeting? Well, capital budgeting is the process by which companies make decisions about which projects, and you can think of projects as also another way of saying fixed assets. And I apologize for my handwriting tonight. I'm kind of sitting in a weird way. I'm kind of on a cramped desk here. So that might help a little bit. All right, so which projects, fixed assets, a firm are to invest in? So whenever a company comes across, an idea or something they need to do, they're going to go through and they're going to evaluate it primarily using quantitative measures, like I mentioned before, NPV, IRR, and the rest of them. We're also going to talk a little bit later on about some qualitative issues we may want to consider as well. So what are some examples of capital projects for the following firms? Target stores, new stores is probably one of the biggest decisions they make. Where to put new stores, whether or not to put one in a town or not, things like that. Payless shoes, it could be stores, it could be production lines. Distribution facilities. Those would be all examples of capital budgeting decisions. Toyota Motors, maybe new cars, new production lines. All these things would take a large investment in fixed assets up front. New production lines, there we go. Okay, so what I have is new cars, new production lines. It doesn't really look like that, but that's what it says. What's the difference between independent and mutually exclusive projects? Well, independent projects, the cash flows of independent projects don't rely on one another. So it's like McDonald's going into a new town where it doesn't have any other locations and there's nothing nearby. So that would be an independent project. They don't have to worry about infringing on another store's or restaurant's location and taking away sales from another location. A mutually exclusive projects are projects that have cash flows that affect each other. So for example, if Walmart were planning on building a new store in Topeka, first of all, they might have several different options of where to put the store. And then secondly, they could only pick one of those options. So with mutually exclusive projects, we have cash flow. We have projects that have cash flows that would affect each other, and typically, in the term mutually exclusive, implies that we can only choose one. So independent projects, the decision is made independently of other projects. Mutually exclusive projects, we typically have to choose one project from two or more potential projects. All right, and we'll work through some examples of that and how we make that decision later on. So the steps to making a capital budgeting decision, the first is to estimate the cash flows, the inflows and outflows. We won't do that in this example. Your case for next week does do that, and I'll show that to you in another video. But you'll get to see how that works, but we won't put together a budget for that. Assess the riskiness of the cash flows. That's also something we're not going to do in this class. It's kind of beyond the scope of the class, but it's certainly something that companies do engage in. Determine the appropriate cost of capital. That's what we did last week. We worked through some examples on how to calculate the weighted average cost of capital for a firm. You made decisions about that in your last case. Determine the values of the capital budgeting decision tools. That's what we're going to focus on tonight. And then also use values of the capital budgeting decision tools to determine if a project should be accepted or rejected. We're also going to do that this evening. So the tools we're going to discuss, and for many of you, these will be reviews. At least the first two will be a review. NPV stands for net present value. So net present value, what we do here is we estimate the future cash flows of a project. We discount them back to today at the required rate of return. And if those future cash flows are worth more than what we have to invest today, then we say that the project has a positive NPV and that it's an acceptable project. IRR stands for internal rate of return. Internal rate of return. And this is the estimated rate of return that the projects will earn back. If you remember from the case we worked last time, in the case it said return on capital. That's what the internal rate of return is in this case. That is the return that we expect to get from the investment. There are some problems with IRR that we'll discuss later. And to solve those problems, we actually use something called the modified internal rate of return. And I'll describe how we modify it so that it solves most of our problems later. The profitability index we'll talk about, it's a form of the NPV that scales everything for us. And then finally, the payback period, and that's just a period of time over which we expect the project to pay back. So I'm going to move on now to page number 2, and page number 2 is net present value. So the net present value is the difference between the current market value of a project and its initial cost. So the market value of the project is calculated as the present value of the project's future expected cash flows discounted back at the weighted average cost of capital, or the WACC. The NPV is a measure of the value added, or the net gain in wealth received by taking on a project. It's calculated as, and this is cash flows, so it's calculated as the future cash flows of a project at each time t, discounted back at 1 plus the discount rate R, and that's going to actually be our weighted average cost of capital. And I just marked over that. That's a little t there. So we're going to discount it back at each cash flow that occurs at time period t back at the weighted average cost of capital for t number of time periods. We take the sum of all those present value of cash flows, and included in that is our initial cash outflow, which you'll see down here, and that's our net present value. So I want to give you kind of a very simple example of this before I work a more complicated example. Let's say your required rate of return is 5%. So that's an annual rate of return you require to invest your money. And let's say that you find a savings account that pays 10%. So you really can't find that, at least in the US right now. You'd have to go to another country where the inflation rate is very high to get a savings account paying 10%, but let's pretend like we can. So what we would say is, okay, if we put $100 in that today, so our time zero cash flow, CF stands for cash flow, is equal to $100. And I'm going to make that negative because that's what we're going to put in today. And so let's say at year one, we're going to receive back $110 because that we are earning 10% interest. So my net present value is equal to the sum of the future cash flows discounted back at 1 plus the discount rate. So on a timeline, it would look like this. At time zero, I put in $100 into my account. At time one, I received $110 because I earned 10% interest, because that's what the account paid. And I'm going to discount that back at my rate of return, my required rate of return, which is 5%. So if I use this equation up here, and by the way, we won't use this equation because we have financial calculators and we have Excel, and they are wonderful, and we're going to use them because they make life a lot easier, but I wanted to show you what this would look like. So my NPV is equal to negative $100, because that's what I invested at time zero, discounted back at 1 plus 0.05, raised to the 0 power, because that's when it occurred, that's our little t, plus $110 positive, divided by 1 plus 0.05, raised to the first power. Oh, there should be a v there. NPV. So that's going to be equal to, this is equal to 100 because 1.05 raised to the 0 power is 1. So it's negative 100 plus I'll use the financial or the graphing calculator for this so you can see all the work. I'm going to take 110 divided by 1.05 raised to the first power. Press enter, and I get 104.76. So my NPV is equal to $4.76. Okay. So this project would be acceptable because your required rate of return is $5. It's actually, or 5%, sorry. It's actually going to pay you $110 or 10%, and we discount that back to today, and the present value of that $110 discounted it back at 5% is 104.76. And so our net present value is the 104.76 minus our initial investment to give us $4.76. Okay. So now we're going to work through some problems. Like I said, I'll start with the BA2 Plus and using these cash flows to determine what the weighted average, or excuse me, the NPV is. So using your cash flow button, I'm going to press in CF, and you'll see I've already got numbers in this. That's not good. I don't know what I've got. So what I'm going to do is press second, and CE/C, where it says clear work, that clears everything out of our cash flow worksheet. So CFO is the cash flow at time 0, it's 0. CO1 is the cash flow at time 1. You see all these are 0. So now I can start putting in cash flows. I'm going to put in negative 150,000 and then enter. I scroll down. Cash flow at time 1 is 40,000 and then enter. I scroll down. So this is FO1, and F stands for frequency. So since we only have one cash flow of $40,000, we're going to leave that as a 1. The nice thing about this, though, is if I have, let's say, 10 cash flows of $40,000, I don't have to put in $40,000 10 times. I can actually put in a frequency of 10 here. But I'm going to leave this alone and go on to CO2, which is 45,000. I'm just going to scroll down again to CO3, which is 50,000. Press enter. Cash flow at time 4 is 55,000. So those are my cash flows. I can scroll back up to double check them. Everything looks good there. So now in order to get the NPV, I press the NPV button. The interest rate is my weighted average cost of capital. On the page it says my weighted average cost of capital is 9%. So I'm going to put in a whole number 9 here and then enter. And then scroll down, press compute, and you get $2,145.41. Okay. And if you're using the BA2 Plus, you can skip ahead here a little bit. I'm going to show how to do this in the graphing calculator as well. So in order to get to the time value of money, financial functions in a graphing calculator like the TI-84, we press apps. Number 1 is finance. And then I'm going to scroll down here and it says NPV, so I'm going to press 7. Really doesn't do a whole lot for me, it just brings this up. So this is the order you need to put things in the graphing calculator. You start off with the weighted average cost of capital as a whole number. So I'm going to press 9 and then comma. And then you put your time 0 cash flow, negative 150,000, then another comma. I don't know the accurate term for what I'm going to show you, but I believe I call it the squiggly parentheses. So we have the parentheses here above it in blue. You see the squiggly parentheses. So I press second. Gives me the squiggly parentheses. Now remember that there's a comma there, and that's a mistake some people make is they leave that comma out, they get an error message, they don't know what's going on. Make sure to put the comma in. Then I can just put my cash flows in, 40,000, comma, 45,000. And that's one too many zeros. All right, now comma, 50,000. Comma 55,000. That's all good. So I'm going to press second. Close the squiggly parentheses up. Close regular parentheses. Press alpha. Then down here where it says enter in the green, it says solve. That's what I want to do. 2,145 and 41 cents. Okay, so just remember, pull up the NPV. The first number is the weighted average cost of capital in a whole number, not a decimal, comma, your time 0 cash flow, comma, squiggly parentheses or curly parentheses, 40,000, and then all the cash flows. There is a frequency, there is the ability to put frequencies in this. I didn't do it, but what you would want to do is after the closing curly or squiggly parentheses, you put a comma and then start another set of those curly parentheses and put the frequencies of all the different cash flows in it. We won't do that in this class because we really don't have a need to, but that is something you can do in that calculator. So we get the answer here of $2,145.41. If projects are so here are our decision rules. So after we calculate this, how do we use it to make a decision? if projects are independent except if the project NPV is greater than or equal to 0. So why equal to 0? Because you say, hey, it's not adding any money back. It's not increasing the value of the company. So why would we accept it? Let's go back to our original example. Your required rate of return to invest in your money into a savings account is 5%. And instead of finding a savings account that pays 10%, we said the savings account pays 5%. So if we said the savings account pays 5%, your required rate of return is 5%. Unless you had a better option out there, you would go ahead and take it because that's your required rate of return. You're happy with it because it actually gives you back what you required. The NPV of this situation, if we were to calculate this out, we would have $105. We discount it back by 1.05 and we get $100. So this would be negative 100 plus 100, it would be 0. Okay. A 0 NPV, an NPV of 0, just earns back the required rate of return. But it does earn back the required rate of return. So an NPV of 0 earns back the required rate of return. And last time we talked about a hurdle rate. Well, that weighted average cost of capital is the hurdle rate. It's the required rate of return on investments. If projects are mutually exclusive, accept projects with the highest positive NPV because those are the ones that add the most value. So if we were looking at a company and it announced a new project that everyone was excited about and it looked like it was going to make them a lot of money, we should expect their stock price to go up, especially if it could be demonstrated that the NPV was going to be high for that project because that's the amount of value, because that NPV represents the increase in the value of the company from taking on the project. So we would expect the stock price to follow that. So that's NPV. We're going to come back to this later on. We're going to work a lot of examples of it. For most of you, this is probably a review. So I'm going to move on now to IRR, or internal rate of return. So the internal rate of return is the discount rate that forces the present value of inflows to be equal to the initial cash outflow and forces the NPV to be equal to 0 when the IRR is used as the discount rate. It is the measure of the rate of return for the project. So if the IRR is greater than the weighted average cost of capital, the project's return exceeds its cost. So think of that as capital cost, our weighted average cost of capital, and there is some return left over to boost stockholders' returns. So for an independent project, if IRR is greater than or equal to the weighted average cost of capital, we accept the project. If IRR is less than the weighted average cost of capital, we would reject the project because it doesn't earn back the required rate of return. It doesn't go over that hurdle. For mutually exclusive projects, choose the project that has the highest IRR as long as it's greater than the weighted average cost of capital for a project. So an example of this, we're going to use the same cash flows. I'm going to go here back into the BA2 Plus. So my cash flows are all the same, nothing changing there. I press the IRR button, it's magical, press compute, and we get 9.62%. So if the weighted average cost of capital is 9%, actually doesn't matter. We don't actually put the weighted average cost of capital in. I just copied and pasted that from the previous page and left it on there. It doesn't matter what the weighted average cost of capital is in this case. When we get to modified IRR, it will. What is the IRR of the project? 9.2, or excuse me, that's not right, 9.62%. It's greater than the weighted average cost of capital, our required rate of return, which is 9%, so we would accept that project using that information. In the TI-84, again, I like this because you can see all the inputs all at once. I would go out here to apps. I would press 1 for finance. And then number 8 is IRR. So I'm going to press 8. Oops. Let me try that again. Apps 1, 8. Apps 1, 8. There we go. All right, so I have my IRR. I don't put anything in for the weighted average cost of capital because that doesn't matter. I start with my negative cash flow, negative 150,000, comma, second, curly parentheses, 40,000, comma, 45,000, comma, 50,000, comma, 55,000. Second, close the curly parentheses, close the regular parentheses, press alpha, and then solve, and I get 9.62%. So just the same as before, 9.62%. So based on that information, we would accept this project because it earns back more than the required rate of return. Just like in the original example with the savings account, the savings account that paid a 10% rate of interest is more than your required rate of return, so you would put your money in it. Right. So sometimes NPV and IRR don't provide the same decision for mutually exclusive projects. So we have two projects here, investment A and investment B. So what I'm going to do and what I'd like you to do is go ahead and calculate the NPV and IRR for both of the investments. The weighted average cost of capital is 10%. So for the first one, I've got my cash flows. I'm going to press second and clear all my work out. So investment A, cash flow at time 0 is 100. When I say negative, I'm actually going down here and pressing this button just in case there was a problem with that. Okay, now I got to do it again because I didn't do it right. 100, negative, and then I want to press enter. If I just scroll down, I'll do it again just to show you my mistake. I scroll down, there was no equal sign up there, and it reverts back to 0. So I want to put 100, negative, press enter. See the equal sign? That means that the number's actually in there. So I scroll down. Cash flow at time 1 is $50, enter. Cash flow at time 2 is $40, then enter. Cash flow at time 3 is $40 and enter. Cash flow at time 4 is $30 and then enter. My NPV, my weighted average cost of capital is 10, so I'm going to put that in there and enter. I'm going to compute that. It's $29.06. My IRR, so I'm going to press IRR, press compute, 24%. That's a pretty decent IRR. So now I'm going to do investment B. I'll use the other calculator for that. And again, you would get the same answer either way. So I'll press apps 1 for finance, 7 for NPV. I put in my interest rate of 10%, comma, negative 100, comma, second, put in the curly or squiggly parentheses, $20, comma, $40, comma, $50, comma, $60, then second, close the curly parentheses, close the regular parentheses, and I get $29.79. Now, the nice thing about the BA2 Plus is I would just press IRR and it would compute and it would give me my answer. In this calculator, I can't do that. I have to go to 1 and then, oops, that's not right. Let's try that again. Apps, 1 for finance, 8 for IRR. Apps, 1 for finance, 8 for IRR. Okay, here we go. Again, I don't put any discount rate in. I just start with my negative cash flow. Negative 100, comma, 20, oops, second, curly parentheses, 20, comma, 40, comma, 50, comma, 60, close curly parentheses, close regular parentheses, and I get $21.03. Oh, this is not good. Well, actually, I knew this is going to be the answer. I planned it that way. Oh, except for that it shouldn't be dollars. That's a percentage. Okay, now I'm going to dramatically say, oh, this is not good, because we get conflicting outcomes. Because if we're going based on NPV, we choose investment B. If we're going based on IRR, we would choose investment A. How do we come up with a decision? So do the NPV and IRR give the same accept-reject decision for the mutually exclusive projects, these up here? No. Why not? So why not in this case? There's two general reasons why they wouldn't. One reason, which is not the case in this situation, is that the size of the projects can be different. Okay, so if you've got one project that's much larger than another one, and you're comparing two different projects, but they have different initial investment amounts and different sizes of cash flows, then NPV we would almost expect to be larger for the bigger project. In this case, though, they're the same initial investment, and they're not, one's not longer than another or anything like that. It's actually in this case because of the timing of the cash flows. So the timing of the cash flows in project A, the bigger cash flows come earlier and the smaller ones later. For investment B, the smaller cash flows come earlier and the big ones later. So in this case, no, it's because of the timing of the cash flows. And I'm going to give you the official answer on the next page. But what I want to do first is construct what's called an NPV profile. So what we do with an NPV profile is that we determine the net present value at different weighted average cost of capital. So that's what I'm going to do here. I will start with project A. I'm going to use the BA2 Plus calculator for this because I can just change the rate of the weighted average cost of capital and recalculate it automatically. It's not that easy in the other calculator. So I have everything in. I got my $29.06 right up here for the NPV for project A. So I'm going to start with 0. So my interest rate is going to be 0, enter. And my NPV is 60, which makes sense because if I add all these up and subtract 100, it's going to be $60. So we're not discounting anything back. So that's $60. My weighted average cost of capital, if it's 5%, my NPV would be $43.13. So then I'm going to go back and press NPV. My interest rate at 10%. My NPV is $29.06, which is what we got before. $29.06. If I press NPV and I put in 15%, then enter, I get $17.18. If I put in 20% and then enter, I get $7.06. And then finally at 25%, I get negative $1.63. Now I want to point out to you that the IRR in this case is 24. So once we went over 24, our NPV went negative, which is what we would expect. Because if I put 24% in here, I'll just show you. My NPV is 0, okay, which is what we would expect based on this. I apologize for if you're hearing this stuff in the background. That's my daughter playing Minecraft on Skype with her friends. So investment B, I'm going to go ahead and I'll put those cash flows in here. I'm going to do the same thing. So my cash flow at time 0 is still negative 100. My cash flow at time 1 is 20. My cash flow at time 2 is 40. My cash flow at time 3 is 50. My cash flow at time 4 is 60. My NPV, or excuse me, my interest rate is 0. And so it's $70, which is what we would expect. If I add all these, this 20, 40, 50, 60 up, I get $170. Subtract out the initial investment of $100 and it would give me $70. If my interest rate is 5%, I get an NPV of $47.88. $47.88. Again, she's just playing Minecraft. There's no, I don't think, if you heard that loud scream, there's no monsters in the basement where she's at right now. If I put in an interest rate of 10%, I get $29.79. I just went down there right before I started recording, and there was a spider on the ceiling, but I killed it. So there shouldn't be any issues going on. I'll check on her if she does start screaming again. And if you can't hear it, then my comments sound pretty weird. So if I put in an interest rate of 15%, I get an NPV of $14.82. If I put an interest rate in of 20%, I get a value of $2.31. And just to show you, if I put an interest rate in of 21.03%, oops, wrong one. Let me try that again. 21.03. My NPV is 0. Okay. But I want to put in 25% down here, so I'm going to put in NPV I is 25, enter, and it'll be negative because that's higher than the IRR of the project. So it's negative $8.22. So what does this tell us? So this NPV profile, there's a point at which we have what's called a crossover point. And the crossover point occurs where the one project becomes less attractive than another project when it was more attractive before. Okay, so the attractiveness of these two projects changes based on the weighted average cost of capital we're using because of the timing of the cash flows. So I'll graph this out. I will give you the disclaimer that I am not an economist. Economists know how to draw graphs well. I don't. On our x-axis, we have our net present value, and that's going to be a dollar amount. On our y-axis, we're going to have the weighted average cost of capital. And at 0% weighted average cost of capital, A has a value of $60. So we'll say this is about 30. This is about 60. So A would be right here. Okay. B has a value of $70. So it's going to be right about here at 0%. So A at 5% is going to be at 43. 5%. It's going to be about right here. At 10%, it's going to be at 2906, so just a little bit below this 30. At 15%, it's going to be 1718, so about right like that. At 20%, it's going to be 706, so maybe there. And then at 25%, we're not even going to consider it, but it's going to be just below the line. Okay, so I'm going to try to draw a line here. This is what A looks like. That's project A. Project A. Project B, like I said, starts at $70. At a 5% discount rate, it's at $47.88. So it's going to be a little bit higher here. $47.88. At 10%, it's going to be at $29.79, so just a tiny bit higher than Project A. At 15%, it's going to be just a little bit lower, $2.36 lower, just about like that. At 20%, it's going to be almost $5 lower, a little bit lower, and then it's $8, negative $8 at 25%. So we see here, I'll make a little dashed line here for B. We have a crossover point right there. Okay. We have a crossover point. That's where Project A becomes more attractive than Project B. Okay. So, and this is probably about 12.5%. So below that crossover point, if the weighted average cost of capital is less than this amount, we would choose Project B, the dashed line. If it's above this amount, we would choose Project A. And we see that up here. Okay. So the NPV is higher after 10%. So this is our 10% amount. At 15%, the NPV of A is $17.18. The NPV of B is $14.82. And so above that, A is less than B. Below that, A is greater than B. So that's why we can get different outcomes, is because that outcome for NPV depends on the weighted average cost of capital. So the choice, the preference of one over the other is not absolute. So why do the NPV and IRR results not always agree? Well, I talked before about differences in size, and we kind of expect that. And we'll talk about that a little bit more when we talk about the profitability index. But in this case, it wasn't the size of the projects. It was the timing of the cash flows. So the NPV and IRR results do not always agree. In this case, because IRR assumes that cash inflows are reinvested at the IRR, weighted average cost of capital, I'm sorry, not weighted average cost of capital, NPV assumes that cash inflows are reinvested at the weighted average cost of capital. Okay. So just to go through that again, IRR, if we're using IRR, it assumes that cash inflows are reinvested at the IRR, at the internal rate of return. So looking at this project, and I'm back on page 4, if we're using IRR for investment A, evaluating investment A, IRR says this $50 that we get at time 1 is reinvested at 24% through the end of the project, through the end of year 4. IRR says that this $20 is reinvested at 21.03%, ignore this, 21.03% for the rest of the life of the project. So if we have larger cash flows earlier on in a project, IRR will tend to give an advantage to that project because it's a big cash flow early in the project reinvested at the 24%. If we're using NPV says, okay, we have $50. What's our assumption about reinvestment? We're going to reinvest that back at the weighted average cost of capital. In this case, it's 10%. So this $50 will be reinvested at 10% instead of 24%. And you might think, well, this is just an academic discussion. It's actually not. I met some people a few years back that worked for Walmart headquarters down in Bentonville, Arkansas. And they actually told me this was a real issue with their board of directors, specifically Rob Walton, who at the time was the chairman of the board of directors of Walmart, one of the top 10 richest, wealthiest men in America. And you had these guys that were probably in their late 20s, early 30s, trying to make capital budgeting decisions for Walmart, and they would get in arguments with Rob Walton. And they told me, one that lasted 4 hours, where Rob Walton really wanted Walmart to use IRR, and they really wanted to have Walmart use NPV based on the differences in these assumptions. So what's the best choice? If you only have NPV and IRR to choose from, NPV is the more, and I mean this not in a political way, but in an accounting way, NPV is the more conservative option because it says we're reinvesting at our weighted average cost of capital. Remember, this is the hurdle rate that we have to jump over in order to accept a project, which kind of makes sense. This is the minimum return that we expect to get in any project we invest these cash flows in. Okay, so this weighted average cost of capital is the minimum return we expect to receive from any future project that we're investing these cash flows in. So that's the more conservative assumption. You couldn't reasonably say that this $50, or you call it 50,000 or 50 million, but that cash flow, we couldn't say that we're going to reinvest that at 24% because that's not our hurdle rate. But that's the rate of return that IRR assumes we're reinvesting at. So typically, NPV is seen as the more conservative and the more realistic assumption, with the weighted average cost of capital being our reinvestment rate. So now I'm going to show you a problem with IRR, and that's multiple IRRs. Not something you're going to see very often, but you might see it if you have a cash flow that's negative later on. And by the way, this is not unheard of. Oftentimes when we end a project, we have to pay to get rid of the fixed asset, or let's say you start a gas station up. Well, when you shut down a gas station, oftentimes to sell the property off, you have to dig out the tanks, or there might be some environmental issue you have to clean up after a project. So oftentimes at the end of a project, there will be a negative cash flow that you expect. All right, so if there's a negative cash flow, we can have multiple internal rates of return. So here what I'm going to do is calculate, again, the NPVs for different weighted average cost of capital. It's going to give you a weird answer where we should have multiple IRRs. So here I'm going to go into my cash flows. I'm going to clear everything out by pressing second and clear work. So I have -60 for my time 0, 155, enter for my cash flow at time 1, and then the cash flow at time 2 is negative 100. Now if you're looking at this, you might be saying, why would you even consider this project? I probably wouldn't. Our negative cash flows are more than our positive cash flows. Typically we'd shy away from this, but it is a way to demonstrate an example of multiple IRRs. So I've got my cash flows in there. Now I'm going to go to NPV. So if my interest rate or my weighted average cost of capital is 0%, my NPV is negative 5. Wouldn't want to accept it there. At 10%, I'm going to calculate it, negative 1.74. At 20%, negative 28 cents. So we're getting closer to 0 where it would be acceptable. At 30%, it's positive. It earns back the required rate of return at 30%, 0.06. And then we take that up to 40%, and it's negative again, negative 31 cents. So what does that tell us? It tells us that our NPV, I put an NPV here, and then my IRR here. My NPV was negative at 0%. So it's 0%. It was percent sign there. It was negative $5. And so what happened was that it slowly went up, and somewhere in between 20 and 30% became positive, and then it went back down like this. So remember, the IRR is the rate of return that sets the NPV equal to 0. So here we have 2 IRRs. And that happened because of this negative cash flow. If our rate of return, our discount rate, is high enough, this negative $100 is discounted enough to be less than, but would be over a 2-year period. I'm trying to do the math in my head really quick. The sum of the negatives, if we discounted this $100 back enough, would be less than the $155 discounted back 1 period. Okay. And I'm going to show you another example of this using Excel, where we can get an exact amount for that, for those IRRs. So why bother with IRR? So I gave you the example of Rob Walton and the folks there at Walmart. And the managers oftentimes like to look at IRR because it kind of gives a safety margin for them. So it provides a margin of safety or a margin of error. So how much can we be off? Because remember, these cash flows that we're looking at are all estimates. So they'll probably be a little bit off. So how much, so when we look at the IRR and we compare it to the weighted average cost of capital, it gives us a good idea of how much we can be off and still make money for our company. So in the case of investment A here, our weighted average cost of capital is 10%. Our IRR is 24%. So there's a pretty wide range, where we can make some mistakes here and still be okay. But if our IRR is equal to the weighted average cost of capital, there's really no room for error on the downside, because if we accept a project that really has a rate of return of less than the weighted average cost of capital, then we're destroying value and we're decreasing the value of the company. So an example I like to give here is, let's say I tell you that the NPV of a project is equal to $10,000. Is this project acceptable? Now, usually in class, I'd say, please raise your hands. And almost everyone's going to raise their hands. One or two people are sleeping or need some caffeine, but there's no excuse for that because you're watching a video and you can stop the video and wake up or take a nap or go get some coffee during the video. So let's say the NPV is positive 10,000, NPV is greater than 0. We accept the project because we just created value for our company. But let's say our initial investment is equal to $100 quadrillion. Okay, that's what $100 quadrillion looks like. Would you make that investment? I hope you wouldn't, because our weighted average cost of capital, our IRR, is equal to our weighted average cost of capital, except for a very, very, very small one at the end of a lot of zeros. So probably wouldn't make that investment even though NPV is greater than 0, especially since there's not that much money in the world. And that's really the point of managers. If you just tell me the NPV, it doesn't give me a sense of how much we're having to invest in order to get that positive NPV. So what can we do? We know IRR is flawed, especially looking at mutually exclusive projects. If you're looking at an independent project, by the way, IRR and NPV will give you the same accept reject decision. No problems with that. But if we're looking at mutually exclusive projects, like the example that we worked through, they might give you different outcomes. So how do we overcome that but still give managers what they want, which is an idea of the return on the project relative, something they can compare to that weighted average cost of capital. And we can do that through what's called the modified internal rate of return. The modified internal rate of return allows the analyst to determine the reinvestment rate for cash inflows for the firm. So before I said, I'll go back to page 4, I said we get this $50 and we reinvest it at the IRR of 24% if we're looking at IRR as our measure here. But with modified internal rate of return, we can actually choose what the rate of the reinvestment rate is. Ignore this comment. I wrote this note without using your textbook. There are 3 approaches to calculating the MIRR. We're using the one referred to as the combination approach. So the combination approach says that we have cash outflows. So those are those negative numbers. We have cash inflows. Those are the positive numbers. The weighted average cost of capital. So we take any future cash outflows, we discount them back at the weighted average cost of capital. We have our cash inflows that we find the future value of or the terminal value of later on in the project. And then our MIRR is the rate of return that gives us an equal amount, makes the terminal value, and we'll work an example of this, of the cash inflows equal to the present value of the cash outflows. So I'll work an example of this, and we'll just go back to investment A. We won't go back to investment A here. We'll actually go back to the first example we looked at, which is this example here. So our time 0 cash flow is negative 150,000, and I want to show you just graphically what this looks like. So at time 0, we invest 150,000. At time 1, we expect to receive 40,000. At time 2, we expect to receive 45,000. At time 3, we expect to receive 50,000. And at time 4, we expect to receive 55,000. So what MIRR does, with that, we find the future value of these cash flows at time 4, and we're going to use the weighted average cost of capital Now, we're not restricted to that. We can actually use any reinvestment rate that we want, and I'm going to show you this later on in another video using Microsoft Excel, where you just put in a rate. But for now, we're going to say we're going to use the weighted average cost of capital. In this example, our weighted average cost of capital is equal to 9%. So I'm going to put 0.09, 0.09, 0.09, 0.09 in here. So we're going to find all the future value of these cash inflows. And mind you, this is a cash outflow, COF. So looking up here, that's the COF. We don't need to discount it back at all because it's already at time 0. But I want to find the future value of each of these cash flows. So the future value of this $50,000, I'm saying my reinvestment rate is 9%. So I'm going to take, I'll use this one so you can see what I'm doing. I'm going to take $50,000 multiplied by 1.09, 1 plus the interest rate, raised to the first power because I have one time period that I'm finding the future value for. So it looks like this. And I get 54,500. The $45,000, so we'd receive this in the project. We'd find the future value in 2 time periods. So in the calculator, I'm going to take 45,000 multiplied by 1 plus the weighted average cost of capital, or my reinvestment rate, raised to the second power. And I get 53,464.50. And then I have my first cash flow that happened at year 1. And then I'm going to reinvest this for 3 time periods, 1, 2, 3, at 9%. So I get 51,801.16 cents. I'm going to add all these up. And I get a total value of $214,765.66. So my MIRR is the rate of return that sets this value 4 years from now to $150,000 today. So I'm going to use this equation here, the present value of the cost. The present value of the cost is $150,000, equal to 214,765.66 divided by 1 plus the modified internal rate of return raised to the 4th power, because that's the number of time periods that we have. So now I want to solve for the MIRR. So in order to do this, I can multiply both sides by 1 plus MIRR to the 4th power. And then I'm going to divide both sides by 150,000. Imagine me doing that in your head. 1 plus MIRR to the 4th power is equal to 214,765.66 cents divided by 150,000. So my answer, 214,765.66 cents, that's just what it's saying here, divided by 150,000. Oops, not twice, just once. One more zero gives me 1.4318. So that's equal to 1 plus MIRR raised to the 4th power. So now what I need to do is take the 4th root of both sides. So I'm going to take 1.431771067, or you can just round that like I did on the page, raised to the 0.25 power, the 1/4 power. It gives me 1.0939. I'm going to subtract 1 because it's plus 1, and that's going to give me an MIRR of 9.39%. Okay. So that's the modified internal rate of return. Now, if you remember, if you look back, our IRR is 9.62. So the modified internal rate of return is a little bit lower because it's not assuming that we're reinvesting at that higher MIRR. Like I said, we're going to work some examples of these in Excel after the end of the notes here. So you'll get to see more of this. The profitability index, I like the profitability index, but you don't see it used very often. So when I talked before about scale, and I gave you the example of the NPV being 10,000 and the initial investment being $100 quadrillion, the profitability index would actually be a good measure to use in this case. What it tells us is the bang for the buck, or it's the present value of the project today for every dollar invested today. So where NPV is equal to $0, where the IRR is equal to the weighted average cost of capital, the profitability index is equal to 1. You can say $1 because that's the way we talk about it, or you could just say 1. The profitability index, in order for a project to be acceptable, the profitability index has to be greater than 1. So for a project, and actually it could be equal to 1 because theoretically we would still accept at that point. For a project to be acceptable, the profitability index must be greater than or equal to 1. And like I said before, what I like about this is it gives us a sense of scale. It tells us for every dollar invested, how much are we getting back in value today. So using the first example we worked through, I'm going to turn on my calculator here. I'm going to go to my cash flows. I'm going to reset these back to what we had initially. So our cash flow at time 0 is negative 150,000. And then I put in enter. My cash flow at time 1 is 40,000, and then enter. My cash flow at time 2 is 45,000, and then enter. My cash flow at time 3 is 50,000, and then enter. My cash flow at time 4 is 55,000, and then enter. And so that's all my cash flows, just like the original example. My NPV, my I for the weighted average cost of capital is 9. So we get the NPV, and we get, of course, what we had originally, which was $2,145.41. The way we calculate the profitability index, there's two ways. The first is the present value of the cash inflows divided by the initial investment so that's equal to the profitability index. An alternative way to get there, if you already have the NPV, the profitability index is equal to the NPV plus the initial investment. Divided by the initial investment. It's the same number. Okay, so let me demonstrate. Using the NPV, I'm going to add to that my 150,000 and ignore that NPV there. It's 152, 145, 41. I'm going to divide that by my $150,000 initial investment. So I'm dividing it by 150,000, and I get 1.0143. That's my profitability index. So what that means is that for every dollar I invest today, the project is worth $1 and 1.43 cents. Okay, so I get a little bit extra back. Now that was using the second formula. If I want to just find out the present value of the future cash inflows, I can go back to my cash flows. So I press CF. I'm going to set the cash flow times 0 equal to 0. So that takes out that initial investment. So now I just get the present value of the cash inflows. So these are my cash inflows. This is my cash outflow. Okay. So I press NPV. I took out that initial investment, got my weighted average cost of capital at 9%, and I get the 152, 145, 41. Then again, I would just divide that by 150,000, and it would give me 1.0143. All right. So what is the PI of the project? 1.0143. And again, you can put that in a dollar amount if you want. Without a dollar is fine too. So decision criteria for independent projects, the PI is greater than equal to 1. For mutually exclusive projects, the higher the better. If NPV is equal to 0, then PI is equal to 1. If NPV is negative, then PI is less than 1. If NPV is positive, then PI is greater than 1. So we want to, for a project to be acceptable, we want it to be equal to 1 or greater than 1. So our last decision criteria that we're going to look at is the payback rule. The payback is the length of time it takes to recover the initial investment from a project with the cash inflows from a project. Financial calculators will calculate payback. I typically don't use the financial calculators to do that because it's different for every calculator. It's pretty straightforward how to calculate it. There's no discounting involved, no interest rates involved. You just add back dollars until you pay off the project. We assume that cash flows occur evenly throughout the year. Throughout, that's a U there, throughout the year. And ignore that if the weighted average cost of capital is 9%, it's just what is the payback period for the project. So we take 150,000 at time 0, it's negative, we add back 40,000. So at the end of year 1, we have 110,000 left to pay back. We add back 45,000. So we're going to add back 45,000 to that negative 110,000. We have 65,000 left to pay back. The next year, we add back 50,000. So we have negative 15,000 left to pay back. So this is year 1, year 2, year 3. Okay. So at the end of year 3, we only have 15,000 left to pay back, but in year 4, we expect to receive cash flows of 55,000. So what we want to do here, again, we're assuming that cash flows occur evenly throughout the year. We're going to say, well, there's going to be a partial year for that last year. So we take the $15,000 that's left. So I'm getting it from right there. I divide it by the cash flows for the next year. So if this could happen at year 2, where the next year we have less than 50,000 to pay back. It's not because it's the end of the project. It's just because of when we can pay it off. So it's 15,000 divided by 55,000. Okay. That's a 55,000 there. So I'm going to do that here. I'm going to take 15,000 divided by 55,000. That gives me 0.272727. Okay. So my project, so this is equal to we're just going to round it to 0.27. So my project pays back in 3.27 years. Okay. So that's our payback period. The payback rule says that an investment is acceptable if its calculated payback period is less than some pre-specified number of years. That's one of the problems, not one we're going to talk about down here, but one of the problems with the payback period is it's really left to managerial discretion on what the cutoff is. So if we said the cutoff is 3 years here, that the project needs to pay back in 3 years, we'd reject this project because it's 3.27 years. It goes beyond that time period. Based on the IRR and the NPV of the project, it's an acceptable project, but based on the payback rule, it's not. If we're using 3 years. Now, if we were using 4 years or 3.5 years, the project would be acceptable. So payback has been become less popular over the years, partially because of this reason. There's no hard and fast rule about when we would cut that off. A lot of people that don't have backgrounds in business or degrees in business or an MBA, they often use the payback rule because it's a very simple way to determine whether or not you want to accept a project. People with more of a business background tend not to use the payback rule. I'm going to tell you that's a mistake. The payback is a measure of the liquidity of a project. How fast do we get our cash back? And since 2008, a lot of consultants have been advising businesses to go back and look at that payback rule. Don't just use the payback rule, but certainly take it into account. So what happened in 2008 and 2009, and I even saw it personally with friends that I knew who owned businesses, is that it became more difficult to get a loan. And not because the business, in my case, a friend of mine who had a business that had been around for 20 years and very stable customer base and very stable profitability, we went to the bank and the bank was honest with him and said, because there's a lot of bad loans on the books, not yours, we don't have the funding to make a lot of loans right now. And so there was a lack of liquidity in the marketplace. There was a lack of cash available for banks to lend out. And so because that was happening with a lot of businesses, consultants said you need to start paying attention about how fast your projects give you cash back. You can't invest a lot of money into a project, even if it gives you a high rate of return, but then not see that cash come back to you for several years because you won't have any way to fund your operations during that time. So certainly pay attention to the payback method. There are 2 problems with the payback rule as a method. One, it ignores the time value of money. We don't discount back the cash flows. There is a method called the discounted payback method. It's kind of a problem because it actually kind of gives you the same results as NPV. But the regular payback method, it ignores the time value of money and it ignores cash flows that occur after the project is paid back. or after the predetermined number of years. So if we said our payback period is 3 years, but then we get a great big, or we expect a great big cash flow in year 4, well, we might be turning down a project that's really good, but doesn't pay back in our predetermined number of years. So those are the two main problems with the payback rule, but it is something we should still consider, and we should still calculate, and we should still look at, because it tells us how fast we get our cash back. I'm going to end this video now, and then I'm going to go through another video where we talk about the project cash flows. And this is going to be very useful for your case for next week, where I'm really looking for you to make decisions, some decisions for the company based on the incremental cash flows and some definitions that we're going to go through there. All right? So this is the end of the first video for March 1st class, and the next video is on D2L.